In the last video, I gave you a broad overview of a few of the classes available in the java.time package. Local date and local time are likely the most common ones you will use. To demonstrate these, I've created a new project called DateTime Project. In the main method of the usual main class, I'll get today's date using now as I've shown you previously. I'll just print this out. Without formatting, this will get printed out in ISO 8601 format, which is a 4-digit year, a dash, a 2-digit month, dash, and a 2-digit day. There are multiple ways to create local dates, and I'll show you 3 of these, all producing a local date for May 5th of 2022. The 5th of May, Cinco de Mayo, is a popular Mexican holiday that's sometimes celebrated in other countries as well. For the first example, I'll call my variable 55. I'll call localDate.of, pass the year, then the month as an integer, so 5, and the day also 5, and I'll print that out. That just prints out 2022-05-05. I'll call the next variable May 5th, but instead of passing the month as an integer, I'll pass the enum value for May, so month.May. That prints the same date out. I can also get a date by passing the year and the day of the year. For May 5th, this is day 125. I'll call this variable day 125 and pass 2022 as the year and 125 as the day. I'll print day 125 here. Running this code, I'll see 2022-0505 again. You can also create a local date instance from a string using the static pass method on local date. The first version takes a single text literal in the same format as the default output, so a 4-digit year, dash, a 2-digit month, dash, then a 2-digit day. I'll call this variable May 5 and print that out. There's also an overloaded version of the parse method that uses a date-time formatter. I'll talk about that one a bit later, but it basically lets you create a date using almost any string in any format. You might expect this class to have getters like getYear, getMonth, and getDay that return numeric values. I've shown you the getYear method in the past. I'll show it to you here again, as well as getMonth using the May 5 variable, calling each from a println statement. Running this code, we get the year as an integer, but the month is returned as an enum constant, May, all in capital letters. I can get the integer value with a different get method, getMonth value, so I'll add that on the next line. If I run that, I get 5 as you'd expect. For day there is no getDay method. Instead you'll need to figure out how you want the day printed in context with one of 3 methods, getDay of month, getDay of week, or getDay of year. I'll print each of these. If I run this code, I'll get 5 as the day of month, Thursday as the day of the week, and 125 as the day of the year. How does Java store the day? For the call to get day of month, Java simply retrieves the day of the month value that is explicitly stored in the local date object. But for get day of week and get day of year, both are calculated. Get day of week is calculated based on the stored year, month, and day of month, and uses an internal algorithm to determine the day of the week from these fields. Get day of year returns a value calculated counting from January 1st. Java determines this by computing the total number of days from the beginning of the year to the given date, considering whether it's a leap year. May 5th is the 125th day of the year in a non-leap year. In addition to these getter methods, this class implements temporal access's get method that takes a temporal field parameter. What's a temporal field? Temporal field is an interface for a class that implements a date-time field. Most of the time you're going to use the chrono field enum that implements temporal field to pick the date-time field you want to get. Let's get year, month, and day again, but using just this one method. I can use chronofield.year, also month of year, and day of month and day of year. Running this, we get 2022 as the year, 5 as month of year, 5 as day of month, and 125 as the day of year. The chronofield enum has constants for both date and time, and I'll be showing you some of the time constants a bit later. First though, I want to adjust my date a bit There are multiple ways to do this. You might expect you could use setters, like set year, set month and so on, but remember that local date, like all the temporal implementations, is immutable. Java doesn't give us any setters for that reason, but it does have methods with similar behaviour. These methods start with the prefix with. These would be setters if this class were mutable, but instead, as it's not, these methods return a new instance of local date with the new value in the specified field. I'll again call these methods from within a println statement. I'll start with the method with year, passing it 2000, which will give me May 5th, 2000. Next I'll call with month and pass 3, so I should get March 5th back. There's also with day of month. I'll pass it 4, meaning I'll get May 4th back. There's with day of year that I'll pass 126 to, which is May 6th in this case. Running this, you can see I get the expected results. I ran these methods on May 5 each time, but the May 5 variable was never changed. Its value stayed May 5th, 2022 after each call. In fact, let me just print that so you can see what's printed. You can see the May 5 variable is unchanged. Like the get method that takes a temporal field, there's a with method with a temporal field parameter. I can pass a chronofield constant and then the amount. I'll call this on the May 5 variable, passing it the day of year on chronofield as the first argument, and second, the number 126 for the day of year I want to change on the resulting date. This is equivalent to the statement just above that calls with day of year with 126. If I run that, I'll again get 2022-0506, so I again adjusted the date to be the 126th day of the year. In addition to just setting fields, you can adjust values by specific values using the plus or minus methods. There are plus methods for each field, so plus years, plus months and plus days, as well as one for plus weeks. I'll print out each of these calls, starting with plus years, and I'll add 1 year. Next, plus months. I'll add 12 months to May 5th. Here I'll call plus days, passing 365 days to May 5th, 2022. Finally, I'll add 52 weeks to May 5th. Running this code, I get 2023-0505 in all cases except the last. When you add weeks, the result aligns to the same weekday. The result will be 52 weeks to the day from the Thursday in year 2022 to the same Thursday in year 2023, which isn't May 5th, but May 4th. You can also use just the plus method, which is overloaded as I will show. Similar to the get and with methods that take temporal fields, this method takes a temporal unit, the chrono unit enum implements the temporal unit interface and is used for this method. Let me show you an example of this. I'll use the plus method, passing 365 as the number of units, and the value of the unit is days, so chronounit.days. That has the same effect as calling plus days, and I get 2023-0505 printed out. What's the difference between temporal field and temporal unit? A temporal field represents a specific field within a date time, such as month of year, day of week, or hour of day. It defines fields we commonly think about in terms of date time components, minute, for example, the month part of a date or the hour part of a time. In contrast, a temporal unit represents a unit or duration of time, such as years, months, days, or minutes. Rather than representing a part of a date or time, it represents the amount of time you might use to measure intervals between date times. On this slide, I'm showing both interfaces and a couple of the methods that would be implemented. I'm also showing you just some of the enum constants on chronofield and chronounit, ones that are pretty commonly used. The get and with methods take a temporal field as a parameter. The plus, minus and until methods take a temporal unit. I'll cover the until method after I talk about the duration class. Getting back to the code, I won't show you examples of minus since they're so similar to plus. There are methods like minus days, minus weeks and so on, which mirror the plus methods. Let's take a look now at a couple of comparison methods. I'll print May 5th greater than today, and then the result of calling is after on May 5th, passing it the today variable. Remember that we created this variable at the start of this video. I'll print the same text, but call is before on May 5th, passing it the today variable. Running this code. The statement May 5th greater than today is false but today greater than May 5th is true. I can use the compare to method to do something similar. I'll copy the last two println statements and paste them directly below. I'll change as after to compare to. I'll change as before on the next line to compare to as well, but in this case I am going to swap the order of the variables around. I'll make May 5 today, so the method is called on today and pass it May 5. Running this code. Instead of true or false, I now get -1 when I compare May 5 to today, meaning the date in the May 5 variable is less than today. The opposite is true, so the date in the today variable is greater than the May 5 variable on the next statement, because a positive result is returned. What if I compare two equal dates? I'll use today's variable and compare that to a call to localDate.now. Running this code. I get a 0 back, which is comparable's result when two instances are equal. I'll copy that last statement and paste it just below. I'll change compare to equals. This time, when I run this code, I get true from the equals method. There's one other method on this class that's commonly used, and that's the isLeapYear method. You can call this method on a local date variable, and it will use that variable's year to confirm if it is a leap year. I'll call this same method, but first I'll subtract 2 years from the May 5 variable. Running this. For the first result, because I'm running it in a non-leap year, I'll get false. 2022 being a non-leap year, but May 5th, 2022 minus 2 years will have the year 2020, which is a leap year. So I'll get true back from the isLeapYear method. I'm going to end this video here before it gets too long. In the next video, I'll cover a couple more methods on local date, and then I'll move on to covering local time and local date time. See you in the next video.